Okay, here's where it gets deep. So right now, up to this point, we've talked about signaling on optical fiber where we're only really talking about a circuit consisting of two strands, right? One transmit fiber, one receive fiber, okay? And as far as the Ethernet data rates go, we were able to support everything up to and including gigabit Ethernet using just those two, 10 gig Ethernet using just those two strands. Okay. Now, we've got standards out there for 40 gig Ethernet and 100 gig Ethernet, and we're working on 400 gig Ethernet. Okay. Now you can do it on single mode or multi-mode. If you do it on multi-mode, here's how we do it. We have a protocol that we call 40G base SR4. 40G, 40 gig. Base standing for baseband transmission. SR standing for short reach or short range. 4 standing for quad transmission. And what I mean by that is that I've got a 12 fiber MPO and I'm running 4 transmit and 4 receive on that 12 fiber cable, each at 10 gig. Okay, why would I do that? Why wouldn't I just come out with a 40 gig that says, hey, let's do a new cable, a new laser, and just have it be on duplex fiber again because it's so much easier than this parallel optic stuff. Anybody know why we would go this route?
Speed.
Speed is right, but it's not speed you think of.
Flight.
Speed of deployment. Okay. The reason that we did it this way is because we already had the OM3 and OM4 fiber that we knew supported it. We already had the VCSEL laser that we knew we could make and sell cheaply for 10 gig. Why not just use multiple instances of that to aggregate to 40 gig? Okay. So for 40 gig, we've got 4 instances of the VCSEL laser operating at 10 gig. Transmit and receive. We use a 12 fiber cable assembly. 4 of the fibers in the middle are just dark. We don't use them. So we use 4 for transmit, 4 for receive. We can go 100 meters on the OM3 fiber. We can go 125 meters on the OM4. Requires us to have a pretty low link loss, 2 dB. Okay. People are doing this in the data center very widely right now.
So this means that when you go to 60 gig, you'll be ready, still be ready.
They won't go to 60 gig. They work in multiples of 10 and multiples of 4. Right. So you saw we went from gigabit to 10 gigabit, went from 10 gigabit to 40 gigabit, 40 gigabit to 100 gigabit, 100 gigabit to 400 gigabit. Right. There's a methodology behind that. Right. And there are people who will say that there may be something in between there, but market adoption suggests that it's going to go that route. It's just it seems to have always worked that way.
What about the 4 dark?
What about it?
I mean, are they potentially useful in case of a damage?
No, because of where they are in the cable. You use, for transmit, you use fibers 1, 2, 3, 4. For receive, you use fibers 9, 10, 11, 12. And because the ones are just in the middle of the cable, they're not used. Okay, in a 12 fiber architecture, they're not used. Right? So it's.
Do you use 4 different LEDs to transmit and 4 different LEDs to receive, or just one big LED to receive?
It's 4 independent VCSELs, but they're contained in one device, right? So if you've seen a QSFP plus transceiver, it's got an MPO connection on it. You plug the MPO cable in. It's one device, but inside that are 4 lasers and 4 receivers. Now, if I do it on single mode, it's a little different. Okay, and here I've got 40G base LR, meaning long range or long reach. Also 4, but the 4 in this instance is actually different wavelengths. I'm doing 4 different wavelengths at 10 gig, and I'm still now able to use 2 fibers. Right, one for transmit, one for receive. There's 4 different wavelengths operating at 10 gig on the single mode fiber. I can go 10 kilometers with that. Okay, so that's a long haul. That's a long haul protocol. Because I've got to do wavelength division multiplexing to make that happen, the transceivers are way more expensive. Okay, so I pretty much only use that for long haul. How about 100 gig? Well, we follow the same idea. Look, I've already got that 10 gig VCSEL that works well. Why don't we just use 10 transmit and 10 receive strands? Right? The problem with that is that if you do it on a 12 fiber infrastructure, you got to have 2 different cable assemblies for one circuit. One 12 fiber for transmit, one 12 fiber for receive. So it's much better if you actually do it on a 24 fiber MPO. So you thought it was cool before when I sent around the 12 fiber. This one's got 24 lined up in the end of it.
Bam.
Oops, sorry. Okay.
But these still called the same thing? Just a 24 version?
12, it's 12 fiber MPO, 24 fiber MPO. Some people will refer to it as base 12 or base 24.
Oh, okay.
Okay. It's two different ways to skin the cat, right? We like the 24 fiber infrastructure for a bunch of reasons, right? It makes more sense. We actually do 24 fibers in the backbone. Remember we had that issue where we had 8 transmit and 8 receive and we had the 4 dark fibers? At the ends of the circuit that might be true, but if I use a 24 fiber cable in the backbone, I can actually light that thing up with 3 of those 40 gig circuits and not waste any fibers. So we like that. That's a little beyond the scope of what we're talking about.
So these high speeds are only going on the MTP, MPO connectors?
Unless you're doing single mode where it's
Which is
a
a
duplex LC. Right.
LC.
Can they terminate those in the field?
MPOs? It's possible, it's not recommended.
That's what I was thinking. You guys will-
No, it's possible, it's not recommended. It's definitely something that you want factory terminated because, I mean, if you've done any kind of fiber connectors in the field, even just single fiber connectors, you know what a pain it is. Imagine trying to do that, right?
You just said that out loud?
Yeah,
You make it pregnant, the whole thing becomes this big.
Yeah.
Just a bit.
yeah, no, it's not
Right.
fun.
Wayfair, man.
So it's the same deal here though, right? Now, and again, we can go 100 meters on OM3, 125 on OM4. All we're doing is we're increasing the number of transmit and receive channels. Okay. Parallel optics, right? So we're not just talking about 2 strands anymore now. It's increments of 4 and increments of 10. Okay. With 100 gig for the single mode, I can do it the same way with four 25 gig signals that are multiplexed and just do it on 2 strands. But again, long distance, 10 kilometers for long range, 40 kilometers for extended range. 100 gig for 40 kilometers on single mode fiber.